Hi friends, in this video I'm going to talk about standard error, which is a slightly more complicated topic as compared to standard deviation, and it's slightly overlooked as well, so I thought about giving it more attention. Now again, this video will not be mathematical, but I'll start with a formula. Now standard error doesn't have a unique formula because it depends whether you're calculating the standard error of the mean. That has a different formula. Standard error of population has got a different formula. And there are other metrics as well, like standard error of the difference in means. That has a different formula. But coming back to what the standard error tells us, now it's got a definition that goes like this. It's a measure of variability of a sample statistic. Now, this is a very confusing and a very tricky concept, especially for someone learning statistics for the very first time. So I thought that a better way of understanding standard error is by using computer simulation. So let's take an example. Let's say I come up with a drug that can treat coronavirus patients. And I want to know how successful this drug could be. Now the standard practice, the clinical practice, is that you have to take some patients and divide them into two groups. The first group receives the drug. We call them the treatment group patients, and the second group of patients do not get any drug treatment. And we observe the difference in the recovery time between these two groups. So let's say I had 20 patients, 10 in the treatment group, 10 in placebo group, and I observed that the treatment group patients on average recovered in 2.5 less days than the placebo patients. But there are some patients who took more time and there's some who took less time, which means there was some deviation, and the standard deviation was 5. Now this was one experiment. We can't conclude that the drug was successful by doing only one experiment, so we have to repeat this experiment over and over. But we can't do that because of lack of resources. So what we can do instead is we can run a computer simulation by using the same information. Now, if you don't understand computer programming, don't worry about it. All I'm doing here is that I'm telling this computer program to repeat the same experiment 10,000 times. I could have used a bigger number, but I'm just saving some time. I'm using a small number. And the standard deviation is going to be 5, and the size of my sample, like it was, is going to be 10. And I just tell this program to run this experiment 10,000 times. And the outcome appears in a few seconds. Here we go. Now this is the outcome. Now this is like as if somebody actually conducted this experiment 10,000 times. So it's almost like the actual population. What we had was just one sample, and we can imagine now as if somebody gave us the real population. Now if I calculate the standard deviation of this population, then that is the standard error. Now I just tell the computer, it's an easy thing to do, I tell the computer program to calculate the standard deviation of this population, and it comes out 2.24. This number is the standard error. Now another way of looking at it is because we have access to the population now, which we normally don't, with the help of computer simulation, of course. Now the actual population is telling us that the average time, recovery time, is 0. If my sample is telling me that the average recovery time is -2.5, while the true recovery time is 0, then this is an error, and this error is called the standard error. I hope I made it a little bit easier to understand. Thank you again for watching. Bye-bye.